Okay, so good day everyone. I am Ian Gabriel Dizon from BSc 3G, and this is dynamics for rigid bodies, and I'm going to discuss an example from absolute motion. So let's begin. A wheel or radius r rolls on a flat surface without slipping. Determine A. The angular motion of the wheel in terms of the linear motion of its center 0, and B. The acceleration of a point on the rim of the wheel as the point comes into contact with the surface or which the wheel rolls. So as you can see here in the figure, this is the origin on where the wheel came from, and it moves in a right direction without slipping. So this dash circle is the origin of our circle. So we have here our point 0. As it moves along, we have a distance of s and a point O prime. We also have the point C, which later become point C prime as it moves in a right direction. Then we also have our initial velocity and initial acceleration. Now for letter A, we are looking for the angular motion of the wheel in terms of the linear motion of its center 0. Now, since the wheel is rolling on a flat surface without slipping, we can easily say that the distance traveled by C prime is equal to the total distance of S. So for S, we can say that S is equal to R, this is R, and we also have a given theta which is subjected vertically, multiplied by theta. For initial velocity, we can say that initial velocity is equal to r multiplied by the angular position, which is also equal to s prime. And then our initial acceleration is equal to radius multiplied by the angular acceleration, which is equal to s double prime. So that is the answer. These are the answers for our letter A. Now let's proceed with letter B. For letter B, the acceleration of a point on the rim of the wheel as the point comes into contact with the surface or which the wheel rolls. So in letter B, we're going to have two coordinates for the x and y axis. So let's first solve for the x axis. For the x, we have x is equal to s minus r sine theta. Since I have told earlier that this theta is subjected vertically, so we're going to use sine for the x-axis. Since this s, we already solved earlier, we have s is equal to r multiplied by theta. We can substitute that value. Therefore, x is equal to r theta minus r sine theta. Factoring out r, x is equal to r multiplied by theta minus sine theta. Now, we're going to differentiate this equation. So, x prime is equal to r theta prime multiplied by 1 minus cosine theta. So in this equation, we can simplify further theta prime because theta prime is equal to the angular position or omega. So we can rewrite it down using omega r w 1 minus cosine theta there. And then we have rw. We can substitute it with the initial velocity. So let's just erase it, and then VO. So I'm just going to see. Here. Next is where we need to differentiate it again. So x double prime is equal to VO prime 1 minus cosine theta plus VO theta prime sine theta. Now we have another theta prime, so we just need to substitute it with the angular position, and then we have an initial velocity which is equal to r multiplied by initial angular position, so it will become as rw squared. So I'm just gonna erase it so we have space. Just take note, the reason why we always substitute different variables is we want to make it we want to simplify it as much as possible. So x double prime is equal to VO prime 1 minus cosine theta plus VO sorry, this is RW squared sine theta. Now we have initial velocity prime, or VO prime. So VO prime is equal to initial acceleration, so we can substitute it. So the final answer for x double prime will be initial acceleration multiplied by 1 minus cosine theta plus r mega squared sine theta. That is our equation for x. Now let's solve for y. So I'm just going to rewrite it. X is equal to double prime AO 1 minus cosine theta plus r omega squared sine theta. Now let's solve for letter y, for the y. So for y is equal to r minus r cosine theta. We have r present in both terms, so we can factor out r 1 minus cosine theta. Then we can differentiate. By differentiation, y prime is equal to r theta prime sine theta. There. Then we have a theta prime. So theta prime, as I've said earlier, is equal to the angular position. Substitute. We have rw. So since we have rw is equal to initial velocity, this one. Substitute it. Initial velocity sine theta. Now we're going to differentiate again. Y double prime is equal to initial velocity prime sine theta plus VO theta prime cosine theta. Now substitute initial velocity prime into initial acceleration, and then the theta prime substitute into the omega, which will lead to VO multiplied by omega. But since VO is equal to RW, we can combine like terms. It will result as RW squared. So y prime is equal to this is initial acceleration, or AO, sine theta plus RW squared cosine theta. So that is our value for y prime. AO, A sub O, sine 0 plus R omega squared cosine theta. Okay, so if our theta, if the value of theta is equal to 0, the value of our x and y will be the value of our x and y will be okay, let's substitute na lang. AO 1 minus cosine 0 plus RW squared sine 0. Sine 0 is equal to 0, meaning RW multiplied by 0, this will be equal to 0. And then cosine 0 is equal to 1. 1 minus 1 will be equal to 0. AO multiplied by 0, 0. 0 plus 0, 0. So x is equal to 0. Next one is y. For the y prime, double prime, AO sine 0 plus R omega squared cosine 0. Cosine multiplied by 0, cosine 0 is equal to 1. RW times 1 is equal to RW. The other side, sine multiplied by 0 is equal to 0. Therefore, AO multiplied by 0 is equal to 0. Therefore, y double prime is equal to R omega squared. So that is a final answer for letter B, and that is the answer for number 1.